link. So maybe after 45 minutes, the link will be disconnected. So kindly join by using the same link. Okay. So meanwhile, in this system, we need to admit one by one. So it takes some time. So anyway, now 25 students are there. We'll
Recording in progress.
in that case, which concept we discuss? Anybody who remembered we discussed basic principles? So one thing, opportunity cost, the foregone cost principle. Other principle we discussed about which
utility.
Very good, diminishing marginal utility. So when you are eating one ice cream, two ice cream, we change it. Okay, very good. So when you are thirsty, very simple example I discussed, you are drinking a water, one glass of water. When you are very thirsty, then your utility or your satisfaction is very high. But after taking 2 glass, just slightly, not so much satisfaction you gain from the first glass, but gradually decreasing. Then third one, fourth, fifth, I told, finally maybe vomiting. Okay. So likewise, that's why diminishing marginal utility. When you are adding 1 unit, the utility is gradually decreasing. Okay. So I think you go got all these points. If any case, if you lost the connection, please use the same link to join. Okay. Okay, let me to share today's section 3. Hope you all can see the screen.
Yes, madam.
Okay, thank you. So section 3, we need to discuss today production function and production possibility curve. Okay, so very first time we discussed what is microeconomics. Then we discussed basic microeconomic principles. Now we are going to learn about production function and production possibility curve. Okay, so in this section, you have to learn about basic concepts of production and what are the stages of production and factors of production for P. And I think factors of production last time also we discussed basically, and production possibility curve or production possibility frontier. Okay, so these things we have to discuss today's section. But remember, today's section, you need to do small calculations as well. Okay. I forgot to tell you to bring your calculators. Anyway, I prepared very basic calculations. We'll try our best to solve these problems while doing the lecture. Okay. So first of all, we will see theory of production. What is production? Okay. So production is a process. First of all, you need to remember it's a process that creates or adds value or utility. Now you know the meaning of utility. Utility means simply a satisfaction. Okay. So another thing, it's just a process. Especially you need to remember the word process. It's a process in which the inputs are converted into outputs. Okay. So there are many inputs. You know, in case of inputs, let's say we in paddy cultivation, we put fertilizer, seeds as inputs. Finally, we get paddy production as the output. Okay, so we are putting inputs to take the output. Simple example, let's say you are cultivating, let's say, brinjal. So you are putting seeds, input, fertilizer, inputs, and getting brinjal, the output. Okay, so likewise, anything you can use as inputs. Basically, we need land, okay, then labor, then we need all other inputs. Okay, so here, let's say capital also, you need machinery, money, and technology, of course, we need. Okay, so these are all inputs we use to take the output, that is the production. Okay, so output means goods as well as services. Okay, please remember, many students just only remember goods only. As outputs, we are getting services as well. Education, okay, and in your case, you are putting inputs to take education. Let's say you are putting money to take good education. Okay, so in schools, students use their energy or school fees to take the education. Okay, in the health service, we are giving money to get a good health service. Okay, so any other activities, we are putting inputs to take outputs. Okay, so every time you need to remember this input-output relationship. Okay, so that is the main thing we are discussing in case of production. Okay, so simply you can say we put inputs to take output. Okay, so I think you got the basic idea of the production or theory of production, input-output relationship. Okay, so so here, see, production function. When we discuss in the production process, the main thing is the production function. Okay, so production function explains the input-output relationship. Okay, I'll show you the function. Then you can see how it works. Okay, so production function may be an equation. Okay, or maybe a table or graph presenting the maximum amount of a commodity that a firm can produce from a given set of inputs during a period of time. Just you need to remember some words here. In the production function, the function may be an equation, just some points are there in your mind, or maybe a table, or maybe a graph. It presents the maximum amount of a commodity that can be produced from given set of inputs. We are giving set of inputs, let's say 10 laborers we are using to produce 10 kilograms of potato. Okay, just for example, during one season. So period of time also you need to emphasize. Okay. So production function. So production is the relationship between input output. So production function explains in equation form or table form or graphical form the relationship. Okay. So if you have any question, you can ask me in middle when I'm conducting lectures. So see, these are the examples. So I told production is a process. Okay. So this is a process. You can see input output relationship. Okay, so input may be a land, labor, capital, or any other seeds, insecticides, pesticides. So these all are inputs. Okay. So we use this process to produce output. Okay, for example, I told we can cultivate a paddy land. Land is there. We can put seeds as inputs. And we can take paddy production as the output. Okay, so then we will see production function. As I explained, it can be an equation. See, production is a function of maybe land, labor, capital, the organization, technology, or any other inputs. Okay, output input relationship as a function. So production function means the functional relationship between inputs and outputs. In the process of production, production is a process or any activity. Okay? So it's a technical relation which connects factors used in the production function and level of the outputs. So what are the factors? What are the inputs we use? And what are the output levels? Okay, so basically, we are discussing this in the production function. So here, different equations we can put. Okay, there's no fixed value. For example, Q. Here, Q is the output, but you can use any word for this. But the main thing when you use an equation, you need to define terms. Let's say here Q, you put as output. Here X, you put as inputs. So F means a function. Okay, function of these outputs. So inputs. So output is a function of these inputs. These inputs may be labor, land, capital, insecticides, pesticides, seeds, or anything. Okay, but the main thing you need to remember, you can use this equation and you have to define. Okay. So normally for this, first we will see two inputs. For example, capital we put as K, labor we put as L. That's why every time we have to define words. What does it mean by K? What does it mean by L? Okay. So output is a function of labor and capital. Okay. So just for example, we took only two inputs here. Okay. Now we will see the uses of production function if we take these two inputs only. Okay. Production, normally labor and capital. Then if many inputs are there, you can change or derive the function accordingly. Okay. So these are the uses of production function. So how to obtain the maximum output, producers to determine whether employing variable inputs costs are profitable. Because every time we need to discuss whether we use these inputs are profitable. If not, we have to change the inputs, especially the quantity as well as the quality of inputs. You know, sometimes we use seeds, but no quality. Okay, so we use money to purchase seeds, but no quality. That means we are using unnecessary costs. That's why every time we need to discuss whether the inputs we used are profitable. Okay, so it helps to get long run decisions. after seeing the production function, we can see after some specific time period, what will happen to the production. Okay? You will see when we use these graphs. So least cost combination of inputs and to predict. So here, after drawing the production function, you can understand least cost combination. Okay, I'll teach you how to get this least cost. That means the minimum cost, because to take maximum output or profits, we need to get the least cost. Cost should be minimum. Okay. So now, before going to these graphs, we will see main inputs. Okay, so the meeting will be end in 10 minutes. Please use the same link to join. Okay. Then, if in case of inputs, there are main two inputs, fixed and variable inputs. Okay. So normally, the factors of production that carry out any production is called inputs, as you know. So these inputs are two types, variable and fixed inputs. Now we will see the difference between these two. Okay. So fixed inputs, for example, land, these machineries, buildings, these are fixed. Variable inputs, for example, we can say labor. Okay, so changing the production, all raw materials, seeds, fixed in a short
Recording in progress.
use the cost of taking this machine, taking this land, taking this building. That cost is called as fixed cost. Okay, so examples, see buildings, lands. So, but you need to remember every time short run fixed costs are fixed, but long run fixed inputs becomes variance. Okay, because you know with the time machines and all getting depreciated. Okay, lands also decreasing the value. So we have to consider fixed inputs during a short period of time. Okay. In contrast, we can say variable inputs. In the long run, all factors of production now varies according to the volume of output. If you need to take more output, more inputs. Let's say more kilograms of paddy, we need to use more and more labor. Okay, so that's why variable inputs. The cost of variable input is called variable cost. So when we use these labors or other raw materials, fertilizers, insecticides, pesticides, the cost we use to take this is called as variable cost. So simply you need to remember the fixed cost will not change with the change of output, but the variable cost changes with the volume of output. Okay, so that's why this is called as variable input and fixed input. I think you got this slight idea of variable and fixed inputs. Any questions in these two cases? Main two inputs we discussed, fixed and variable inputs. The cost incurred or cost used to get these inputs are called as fixed cost. We used to take variable inputs are called as variable cost. So these are two main cost components: fixed cost to buy fixed inputs, variable in cost means to buy variable inputs. Clear up to now? Hope you all can hear me. Any questions you can ask? Bandara, any questions? Or got the point?
No, madam. You get the point.
Okay, thank you. And this is the production curve. Okay. So here, I told normally for your easiness, we'll use only two inputs. But remember here, first I took capital for K. Here I use C. Then I need to show you, we can use any letter, but we need to emphasize. So we need to clarify, what do you mean by Q? What do you mean by L? What do you mean by C? Then only you can get marks during your examination. Okay. So here, first of all, you need to draw two axes. So here the main thing, just to understand what is y-axis, what is x-axis. Okay. So I hope you all know output-input relationship. Output depends on input. That means output comes in the y-axis, inputs comes in the x-axis. Clear how to recognize two axes? Output dependent variable we put in the y-axis. Any students understood the case? Let's say you are applying nitrogen fertilizer to get crop yield. Let's say any crop. Okay, let's say same example, brinjal or lady's fingers or pumpkin. Okay, so you use fertilizer to get the output. So output depends on the application of fertilizer. So that's why output is the dependent variable. I think you got the clear idea of selecting Y and X, because it's very important in the production curve. If you mix these two axes, your all answers in your calculations may wrong. Okay, so that's why every time you need to remember the selection of X and Y variables nicely. Okay, so now you just draw two lines and label the axis. If units are there, you have to put the units. Okay, let's say output in kilograms, labor maybe man days, capital if we use any fertilizer, any other money or any other thing, you have to put here the units. Okay, so first select the two axes clearly, X and Y, then label the axis and put units. Here one problem is there, no units. Okay, so remember every time you have to put units. Then see, when we use the input, gradually the output is increasing, and gradually it is becoming constant. So after some time, it may be decreasing even, because, if we use many labor or many fertilizer to a particular crop, so, some tolerable limits are there. After some limit, the production may decrease. More and more labor, output decreases. More and more capital, output decreases. Okay, so that's why the shape of the production function normally we keep like this. Okay, so afterwards, now we will see various concepts of production. Okay, so first of all, we will see what is total product. So it's very clear, total volume of goods produced during a specific period of time. Okay, so here normally total product can be raised only by increasing the quantity of variable factors. Maybe you are using inputs, more fertilizer, more labor. If we use more labor, more fertilizer, you can increase the total product, but you know the shape of the total product curve. It is increasing, but after some time, it tends to decrease. We are going to learn these things with some graphs. Okay. So first we will just identify the theory portion. We'll do then calculations, basic calculations. So the total product, I think got the idea, total volume of goods. But the average product means, average, basic mathematics. Okay. So we have to divide by the number of units, total product. When you divide by number of units, called as the average product. For example, average number of students Okay, now hope all join. Yes, before we had 42 students. Okay. So then, hello, hope you all can hear me.
Yes, madam.
So we were discussing about each product. So here you can see that divided by two small calculation now, and please try whether you can do this question by yourself first. Okay. Good. total
Recording
product
in
divided
progress.
by number of units. So now we will move to one small calculation and see, because in this system we have to admit one by one. That's why it takes time. Okay, so okay. So average product, basically, you know, the total product divided by of units. Okay, so here's small example. Hope you all can see. So Cross Farms is engaged in production of sugarcane. The major factors of production in the businesses are land and labor. The farm has a land mass of 10 square kilometers and it employs 3 people, each working 10 hours a day for 100 days. During the financial year 2012, they produced 120 tons of sugar cane. You need to calculate the average product per unit land and labor. Okay, since this is the first calculation, I just give you the way of thing. Then I'll give you another calculations to do by yourself. Okay. So here, first of all, we need to take the total product. Okay. So total product is 120 tons. So first of all, you need to take average product per unit of labor. Sorry, unit of land. So it is given here. Land mass 10 square meters, employ 3 people, and here you can take 120 tons of total output. So you need to take, no need to take the labor here. You have to consider the land, average product per unit of land. So if there are 10 square kilometers of land and 120 tons of total output you are getting, so average product per unit means you have to divide by number of units. That means 10 square kilometers. Is it clear, first one? Everybody?
Yes,
Sorry? Hello? Is it clear, one equation, first one?
yes, madam.
Yes, madam.
Okay.
Yes, madam.
Okay, then the same way you can take this total output is there. Then labor hours normally we can calculate. So from the labor hours you can calculate what is the average product per unit of labor. Okay. So accordingly, when all informations are given, you can calculate this average dividing by number of units. Very easy. Now marginal product is somewhat different. That means it's easy, but you have to think in different way, because you may remember your marginal utility when you add 1 unit. Okay, that means change. When you are changing 1 unit, how you are changing the total product. But the average product, you remember, you divide by the total production is divided by number of units. But here, how additional unit change the output. That we can say addition to total product resulting from the addition of one unit of input. Okay, you may remember addition of 1 ice cream change your satisfaction. How it adds to your satisfaction. So likewise, marginal product means the addition. Only the change, instead of first one we used just the total production divided by number of units. Okay. But here you have to take change in total product, change in N. Okay. So what's the difference here? Average product, total product, and N only. But marginal product, change in total product, change in number of units. Okay. So now it's very easy to remember these two formula. Now we'll go to do small calculations afterwards. Okay. So I think average product and marginal product is clear to you all. Average product, we take only the total product divided by number of units, but marginal product, change in total product, change in number of units. Okay, how the additional unit adds to the total product. Okay, so here, small calculation. I think now you can do easily. Try to calculate average product and marginal product. Here labor units and capital are given. Total output is given. So you need to calculate because capital is constant continuously. This fixed cost, capital. So variable cost is labor. It is changing. Okay. So average product. Try to calculate average product at least up to 4. And calculate and put the answer in the chat box. Then I'll see who will do the first. First one, average product and marginal product 0. Start one. And second one, average product just divide by total product, total output by number of units. But the marginal product, change of output, change of input. Who calculated first? Let me to see the chat box. No answer yet. See, you can see change of input every time 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Change is 1. So it's very easy to calculate the marginal product and average product. So when we are meeting physically also, we'll do these calculations and graphs because I think some students, we need to calculate this on the board. Then you can identify very easily. Anybody who calculated? Till now, I didn't see any answer. First point. Okay, please practice with the time, then I'll teach you. Okay, so here. Okay, so here you can see clearly. First 0. Then is it clear how to get 10, 10 here? Who got the answer? Total output is 10 divided by 1. That is 10, 10. Marginal product also 10. Clear to you all? Then see the second one.
Excuse me.
Marginal
What should be
product.
best?
Hello? First see the average products. Okay. 10 is okay to you all. Total product divided by number of units. 10 divided by 1. Then here total product is 30 divided by 2. Number of 2 labor units. 15. Then 60 total output divided by 3. 20. Average product only we are seeing. Okay. So here you can see 80 divided by 4. Number of 4 units. Here 20. So accordingly, I think all clear. That's why I told it takes only 5 minutes. If you are very good, not good even, good, so in mathematics. Okay. So average values. Total. Can't you hear us? Bandari, did you say something?
Yes, madam.
Okay, sorry, I didn't hear. Now I can see hear. So I think I hope you all got the answers, isn't it?
Yeah.
What did you say? Okay, great.
What should we get as the units, madam?
Unit. Yeah, very good. That means labor hours. Normally we use, let's say, one labor, second, third, 1, 2, 3, 4 labors. Let's say just we are using people here. Okay, just for your easiness, I didn't put units, but anyway, very good question. Okay, labor maybe man. Normally, labor we are using labor hours, man hours. Okay, but here maybe one labor, 2, 3, 4. Likewise, we can increase the labor units. And here capital maybe let's say machine. Anyway, we can use 10 same value per machine. Okay, so here also when you use one labor or no labors, the same machine we have to use in the production process. That's why fixed cost will not change with the change of output. Okay, very good question, because you can learn many things here. Variable cost is changing with the change of output, but fixed cost is not changing with the change of output. Fixed cost may be anything, maybe the value of machine, maybe value of any fixed land. Okay, so anything you can keep as fixed value in short run, especially. Then you have to take only the variable cost components to calculate the average product and the marginal product. Now, got the point, Bandara? So if you are given any values, you can use here values. But here just numbers only just for the first instance. Okay. So here average product, marginal product, I think then average product is okay. Then I teach you how to take the marginal product. Marginal means just the change of total output. Here 0, 10 means change is 10. Divide by 0, 1 means 1. That means 10. Here total output change is 10 to 30, 20. Change of labor 1. So only you need to take the change of output only to calculate the marginal product, because the change of input is fixed here. I mean 1, 1, 1, 1. Divide by 1 means we can take the same way. Now clear how to take the marginal product?
Yes,
Okay. Anybody? So then what you can observe here? Just see, now I gave the values also. So normally I used to give this first slide to calculate the second one, but I have given the answers as well. But after seeing these values, what you can see? What happens to the average product? Anybody? Yes, Ranavira, what you can see? 0.36. What you can see after seeing the average product value? Yes. Increasing and
decrease average
very
product.
good. Increasing gradually decreasing. Very good. And what happened to the marginal product? Decreasing. What will happen? Here,
Recording in
again.
progress.
You practice by yourself when I share these PPTs with you. Okay. Okay. Then we can draw the graph accordingly. Okay. So let's say I am providing you graph.
Excuse me.
Yes. Yes. Any
Isn't there any
question?
use of capital, madam?
Sorry.
Isn't there any use of the capital, madam? There is the K, or there are tens in this chart.
What? The units, Bandara?
Madam, the use of capitals, there is a an
That
example.
means which type of
The use of
capital you
these
are
tens,
asking? Yes.
the capital K.
Yes, yes, capital. Yeah, that's not a fixed value. Very good question. Why you are asking why I use K for capital?
Yes, madam.
Okay,
And what
okay.
is the use of
You
that
can
in
use,
this?
yes,
In
you
this
can use any
equation?
word. See, normally in the internet, you can see the capital for K because this is a Latin words we are using now. L for labor is okay. Normally capital, if you use C, it's also okay. Okay, but in the internet, many graphs you can see L and K for labor and capital. That's why I use the same for your easiness. Otherwise, you can use any letter, but better to mention what does it mean. Very good question. Now, Bandara, clear?
Yes, madam.
Okay, okay. So, so accordingly, we can draw figures like this. Okay, so gradually increasing, and here it is decreasing. Okay, so now we will see only the torque curve. See, gradually increasing, decreasing. See the
Excuse me, miss.
sorry,
Excuse me.
sorry, coming to. I didn't
Miss,
hear.
මේ average product කිව්වහම මේ total product එක number of units වලින් බෙදනවානේ.
Yes, yes, yes. Number of units. See here, total output is 10. Number of units, 1. Here, total.
capital
I
නැද්ද?
capital fix name.
Fix miss.
Your machine. So same capital you use, but the labor unit is increasing because the variable cost, labor is the variable, it varies with the production level. But the fixed cost or capital will not change with the output level. Okay, from this you can learn a lot. So here you can see, if we consider the total output only, gradually increasing, up to here increasing, it becomes constant, here constant, gradually decreasing, but constant. See here, total product like this, increasing. But here you can see total output increasing with increasing rate. 10, 30, 60, then 80, 95. That means the difference is gradually reducing. That means here it is increasing at an accelerating rate. Veging වැඩි වෙනවා. increasing at decreasing rate, then gradually decreasing total product. Okay, I just described these 3 stages as well. Then the same way you can take the marginal product and average product. See, marginal product is maximum here at that point. You can see my cursor. Hope. Okay, so here we can see when the marginal product is maximum. We'll see from here. Marginal product is maximum at that point. 30 is the maximum. So at that time, labor is 3 units of labor we use. Capital say. Total output is 60. Okay. So the same thing we can put in the diagram. See, at that level, 3 are waiting. Okay. Here we use 30 and 3 labor. Okay. That time, maximum marginal product you can see. Okay. So accordingly, you can see the average product level as well. Average product is maximum. See, when it comes to 4 labor units. Here also you can see the difference. Okay. So every time you can see when it touches. See here, average product equals to marginal product at that time. We'll see at that point. Because slowly you can see the diagram. Now I'll explain because in the physical class, I'll teach you these graphs again. Here, just observe the marginal product and average product. When it comes the same value, we'll see with the figures. See average product, when average products same as marginal. See, 1 point came, average product is same as with the marginal product. At that time, we use the total output is 80. We use 4 labor units. Okay. So every time you can just compare with these values and the graph. Then if you see these together, then easily you can recognize the points. Okay. So here when the maximum point before reducing, you can say marginal products become 0. Okay. So we will see where marginal products become 0. See. At that time, total product 2. That's why marginal products, the change becomes -4 and -8 because it is reducing values. Okay, so that's why in the graph you can see after that it goes minus. After 0, here the minus values. Okay. Now got slight idea about this table and the graph. If still any question you can ask. Because gradually you need, then any type of question you can answer. Clear to you all? Or should I explain again?
Can you explain it again?
Oh, okay, great, thank you. Okay, so here, first of all, I am giving you 2 inputs. Okay. Marginal cost. Okay. So many students are. So here, first of all, I have given only these 2. Labor, capital is not changing, and labor is changing, and total output is given. Okay. So you have to calculate the average product and marginal product. So average product is very easy to calculate. Total output divided by number of units. Now, here you have to forget the capital because it is not changing with the level of output. So our job is with labor and TP. Total product or total output. Okay, you can use any word, TO, TP or anything, but you have to write what is it. Then average product is clear. 10 divided by 1, 10. 30 divided by 2, 15. 60 divided by 3, 20. 80 divided by 4, 20. So on. So marginal product means change of output, change of input. So here all together change. First one we will see what is change of output. 0 to 10 means what is the change? 0 to 10. 10. Very good. 10. And what is the change of input? 0 to 1.
1.
1. Very good. Yes. Then 10 divided by 1, the answer is 10. Here, what is the change of output?
20.
20. Very good. What is the change of input?
1.
1. Very good. Then 20 divided by 1 means 20. Then again here, change of output, 30, 60.
30.
30. Very good. Then change of input, 2 to 3. 1. Then answer is 30. Now clear? Accordingly, all values are taking the change only. Change of output, change of input. Average means total output, total inputs. Now clear how to take average product and marginal product?
Yes, madam.
Okay, great. Okay, those who didn't get the point, you can ask from Arvind, Bandara, or anybody, okay? As I see your names. Now we'll move. Again, this will be disconnect. Please join again, okay? So total product curve, I think again clear to you all. Output, labor, you can draw like this. And this again, I am just summarizing. The total product, again, you can say if you take the other way. Average product multiply by number of inputs. Okay, other way. The same way you can, there are many ways of getting total product as well. If you know the average product, you have to multiply by N. Because to take average product, we divide total product divided by number of inputs. Okay, so if you have the marginal product, so summation of marginal product also the total product. You can just compare these values with this. Okay. So there are different ways of calculating total product by using average product and marginal product. The way we did it before, again we can do to calculate total product as well. Here also clear to you all how to calculate total product by using average product, how to calculate total product by using marginal product. The same way we used before. Clear? Bandara? I think Bandara is only answering. Hello?
Yeah.
Hello? Got it? Got the point?
Yes, madam.
Okay, thank you. And we'll continue. If you lose the connection, please join again. Today, somewhat problematic Zoom link. Okay, so here, one example I am giving you. Total inputs are given, total product is given. Okay, I think now it's easy for you to calculate all values. Okay, so let's say I'm just giving values and draw the diagram. So it's easy, you can identify total product is gradually increasing with an increasing rate, increasing with decreasing rate, and going down. Okay, so accordingly, average and marginal product curves also changing if you are given the values. Okay. It says diminishing returns. That means gradually decreasing return. You can see after seeing this,
Recording in progress.
capital also as fixed. Okay, so especially in the law of production function says short run production function with at least one variable keeping the quantities of other inputs as fixed, as we did before. Okay, so it says, the law says like this: if one variable used more and more units, just imagine the labor, keeping other inputs fixed. Just remember capital. The total product will increase at an increasing rate in the first stage. In the second stage, total product continuously increase, but at diminishing rate. That means decreasing rate. Just remember the graph like this. Increasing rate and decreasing rate. Then, eventually, total product decreases. Okay, so that is the law of variable proportion. Okay, so here the same example I took just to explain these stages. See, first stage, gradually increasing the total product with the increasing rate. See, 10, 30, 60, very quick increasing. So average product also increasing. Marginal product also increasing. But see the second stage. Okay, so gradually increasing but decreasing rate. See the average. See 20, 90, 80, 16, 14. That means gradually the gap is reducing. That means decreasing rate. Then marginal product is gradually decreasing. Average product is gradually decreasing. This increasing but decreasing rate. Okay, so finally, third stage, this becomes minus. So in the graph, we can show clearly like this. First stage, second stage, third stage. See, first stage, gradually increasing rate. At that time, both are increasing. Total product are increasing, marginal product, average product. But after some point, when marginal product becomes maximum, gradually decreasing, but the average product, total product is total increasing. That's why average product still increasing. But after it becomes maximum, it is gradually decreasing. Okay, so no need to remember this when you have figures like this, the values, automatically you can observe the real case scenario here. Okay, so here again, I summarize stage 1, stage 2, and stage 3. Up to now, it's clear to you all how you change this total production and the labor, I mean, the input and output relationship with stages. Hashini, is it clear? Or any question?
I can't understand, madam.
Sorry? I need to explain again.
Yes, madam.
Okay, okay. That means here, see, first of all, is it clear this numbers and stages? Hello? Hope you all can hear me.
Yes,
Yes,
madam, we
madam.
can hear.
Okay.
Yes,
So
madam.
here, let's say that we are just discussing about law of variable proportion. The link okay, so we'll continue learning. Okay, going to share again the section.
Recording in progress.
Okay, so law of variable. Hope you all can hear me.
Yes, madam, you can hear.
Okay, so law of variable proportion says when one variable is changing, I mean using more and more units while keeping other inputs fixed. You know, for the production process, if we take the production process, we use many variables. But just remember, we are changing only one while keeping others constant. Then the total product will increase. Then just imagine our graph. Increase at an increasing rate in the first stage, and then increase at diminishing rate, that means increasing with decreasing rate, and finally decreases. That is the law. Okay, nothing else. Just when one input is changing while keeping others fixed, total producing at an accelerating rate at the first stage, increasing at decreasing rate at the second stage, and gradually decreasing at the third stage. Okay, so it shows here. Here also see increasing at increasing rate, total product, increasing at decreasing rate, and finally decreasing 108, 100. So then marginal product becomes 0, average product decreasing. Okay, so these all clearly you can put the lines of 3 stages here. Okay, so here that's what we draw here. The same values we put, and we separated first stage increasing at increasing rate, increasing at decreasing rate, then decreasing. So at that time, you can see after that point, marginal product becomes minus. So these are the main 3 stages we showed here. Increasing at an increasing rate, increasing at decreasing rate, and gradually decreasing. X means any output, sorry, input. Y is the output. Now clear? Those who didn't get the point first. How to explain 3 stages are clear to you all? Hello? Hope you all can hear me.
Yes, ma'am.
Okay. So questions now, these 3 stages now clear? At this stage, yeah, at this stage, what farmers should do? Increase the output, input more and more because output is getting increased. But at that stage, increasing but decreasing rate, then they should see just some changes. What we can do, because increasing and decreasing rate means gradually the profits are decreasing. Then here no profits at all. Then is it useful for any farmer to use more and more inputs after that point?
No, madam.
No, it's useless. Very good. Because just only cost is there. Because for this input, let's say labor, maybe fertilizer, for anything we have to give money. So only cost is there, no return. Output is decreasing. Okay. So I think after seeing this graph, you can explain many things. How to use inputs, how these 3 stages are changing, why it's changing, how it's changing. So everything you can explain nicely. Okay. Now these are the stages in law of variable proportion. First stage, I think you can explain very nicely now. better than these wordings. Okay, increasing returns. Then every time just remember this graph and this table when you are explaining these stages. First stage, increasing return, total product is increasing in increasing rate. Average product also increasing and reaches the highest. Marginal product also increasing, become equals to average product at the end of the stage. Marginal product is more than the average product. Now we will see whether it's correct or wrong. See, marginal product, you can see the table as well. Okay, so I think here is more clear. Our total product is increasing, marginal product also increasing, average product also increasing, but marginal product is increasing more than the average product. Okay, so everything you can see after seeing the graph. So that's what we explain here. Marginal product is more than the average product. Clear up to now? First stage? Or any question?
No, madam. It's
Oh, great. Now we will see the second stage, diminishing return. So you can explain just while imagining the graph. Total product is increasing, but at diminishing rate. That means decreasing rate. And it reach at the highest at the end of the stage. See, is increasing at decreasing rate and reaches the highest. According to our values, 1, 1, 12. See, after that it is decreasing. Okay. So, now first point is okay. Second, average product and marginal product are decreasing, but both are positive. See, average product, marginal product, both are decreasing. This is also decreasing, this is also decreasing, but in positive stage. Negative means going below this x-axis. Okay. So that point is also okay. A marginal product becomes 0 when total product is at maximum at the end of this stage. See, total product at the maximum, marginal products become 0 at the end of this stage. So second stage ends from here. Okay. So then marginal product is lower than the average product. See, you can see here. Marginal product is lower, average product is more than the second stage. Why is it? Because total product is gradual increasing. Even though it is decreasing rate, it is increasing. So average product means just total product divided by number of units. So average product also increasing at decreasing rate. This also increasing. Then this is more than that. Average product is more than the marginal product. Now second stage also clear to you all? Or any question? Hello? Hello? Is it clear? Second stage.
Yes, madam.
Okay. In the third stage, negative return, total decrease, total product is decreases, product is negative, average product is decreasing,
Madam,
but
excuse me, madam.
yes,
Can you explain it with the second
yes,
stage?
yes, we'll see. Let's say we use labor, okay, and let's say paddy, or let's say just easy example, your nitrogen level. Let's say you are using urea and the production, okay. So if we use more and more urea, so the production is gradually increasing. When you know any tree, a tolerable fertilizer limit is there. Then while adding 1 unit, additional, the production is increasing but gradually decreasing. That means the additional output given per unit of input is gradually decreasing. Even though you are adding 1 unit of nitrogen or 1 unit of urea, the marginal product, the adding 1 unit, the change of product is gradually decreasing. That is the way of marginal product. But even though the total product is gradually increasing, that means the tree will grow, but when you add 1 unit of urea, per unit production is gradually decreasing. Additional product. That's why the marginal product is gradually decreasing. Now clear, Bandara, with example?
Yes, madam. Yes.
So gradually you can see, then if you use more and more nitrogen, what will happen? The tree will definitely die. Okay, so that's why adding more nitrogen, the additional product will not gain at all. That's why gradually it is decreasing. No production at all. Okay, so that's why here return, we are getting negative return, only cost. We are increasing nitrogen or fertilizer, urea or something only, but no return at all. Okay, so here with this we will go for isocons, another new one for you. Iso means equal, cons means what? Just imagine what may be cons. Huh? Easy to remember. Quantity. Isocont. Same quantity. So, you know, sometimes if we use 2 inputs, let's say labor and capital, we can take same level of output. Okay. So, in this case, we told the word, we use normally the word isocont, same quantity. You can change the quantity of inputs, let's say 2 labors and 5 another, let's say labor and for capital money you use, you are changing the amount, but you are getting the same level of output. More labor, maybe more capital. 2 units of labor, 3 units of capital or money. Okay, so if you are changing these inputs also, you can take the same level of output. We say isocons. Okay, so the slope, marginal rate of techers, we'll see the graph with the graph. See, so here you use 2 inputs, capital and labor. Okay, so isocont or equal production curve, same level of production if you use this much unit of capital, this much unit of labor, this much unit of labor, this much unit of capital. See, these are same production levels. Let's say the production level is 100 unit output. Let's say 100 kilograms. 100 kilograms of paddy you are getting as output by using the worth of 1 lakh machine and 10 labor units. Okay. So you can see here, capital also changing, labor also changing. Let's say capital, the machine units or money you are changing, and you are taking the same output level. So there are different combination. Here 20 labor, 1 capital. 18 labor, 2 capital. Just see here, you are using some equipments. Okay, here labor units, people. But you are getting the same output. So that is isocont. Okay. So here we can say isocont map because here let's say 10 kilograms of paddy, 100 kilograms, 200 kilograms, 300 kilograms. Production levels differ. Different input levels we use. Okay. So if we use this isocont map, see here, 2 inputs we use and we get one isocont. Another more and more inputs, another isocont. Another isocont. Okay, so different isoconts we use. We can take the isocont map. Clear up to now? Okay, very good. Same level of output, but different combination of inputs. Okay. So let's say you use here, please understand clearly. One input 2, here one production curve. Just focus on your red line. Another input, let's say input 2, just keep one line up and down here. See, input 2, input 2, input 1, input 1. This axis put this upward. හිතන්න මේක උඩින් තමයි මේක තියලා තියෙන්නේ. See, x and y, same x and y here. So for this x and y, red lines are the lines. For this, green lines are the lines. Zero line, see the red line for these two axes. But for these axes, with the green, understood these two graphs, one put on the other.
No, madam.
No, okay, very good. That means, let's say, just forget this one. Just think about these two only. Input 1, input 2. You use maybe land, labor here. Okay. Now, these red 2 lines, these production curves, before we put like this. These are the same lines we use now. Now, red and this input 1, input 2, clear?
Yes, ma'am.
Okay. Then use the same one. Input 2 means here input 2 same. Here input 2 same. Just put this one on this one to make a square. Make a udding, make a තියලා කියලා නිකන් හිතන්නකෝ. මේ graph එක එන්න ඕන just in this way. මේ axis එකට here, in green one, here. So many lines may be in between, but you can identify some lines maybe touch each other. තේරුණාද මෙතෙන්ට එනකම්? දැන් මේ වගේ graph එකක් උඩ මේක තියුවට පස්සේ maybe many isoconts like this. So 1 point came, because for your easiness, I didn't keep these all isoconts. I just kept only 2 isoconts in this graph, 2 isoconts in this graph where they are touching. Understood up to now? Just take 2 lines, 2 normal line graphs and put one on the other. Understood? Not yet.
No, madam.
Understood, Aravindu?
No, madam. Please explain
Oh,
again.
okay, good. I'll explain again. So just see Here y-axis, here x-axis. Now clear? Two axes. Input 1 and input 2. Is it clear? Two axes.
Yes, madam.
Then these two axes, see this red line. Just imagine there are many red lines like we draw isocont in this first graph. See in this first graph. Yes, this one. See, many isoconts. So likewise, here also, there may be many red lines here. But your VE sinners, I took only 2 red lines. Is it clear now? Only
Yes,
one.
madam.
Okay.
Yes.
Now just think, here not this like this, here also separately we put input 1, input 2 here, this side. And draw these green lines like this. Now understood? See my right hand side. Input 1, input 2. I draw the green lines now normally. Now understood?
Yes, madam.
Okay. Now just remember, we put this red one first and we put this green one on this one. Make උඩින් මේක තියුවා කියලා හිතා. ඒතර මේක යනවනේ අනිත් පැත්ත ගෑනවනේ. Understood?
Yes, madam.
Okay. Then when you put this on this, first we draw, just try to draw separately 2 lines, 2 graphs. Then put one on it. Then some points may come where they touches each other. These points are called as efficient points. Okay? Because same inputs they used, same production levels they took. There are many efficient points. These are isocons, same level of quantity of output. Okay? So W and V are the efficient points. Now understood up now clearly?
Yes, madam. Now we got it.
Very good. Now draw separately by yourself, then put one on other, then you will remember, okay? Because in the classroom, I am just drawing 2 graphs separately and I am put one on the other. Then students can understand first time, okay? So sorry for you because I am just teaching you online. These graphs maybe, it takes time to understand. It's okay now, I hope you all understood. Let's say we just here one point, here another point. So there may be many points. When we combine these points and draw a graph, wait, I'll come this to it later, like this, related to 2 products, because by using inputs, we produce 2 products. So when we combine these all lines, when we draw a line like this, after combining these all points, efficient locuses, efficient points, we draw this type of graph. It is called as production possibility curve or production possibility frontier. Because we use many, we produce 2 products, we use 2 inputs, but we got efficient points. After matching or after combining these points, we can draw production possibility frontier by using those inputs to produce these 2 outputs. Okay. So the definition of or the meaning of production possibility frontier means to measure the efficiency of a production system when 2 products are being produced together. Okay, so management uses this graph to decide the ideal ratio of units to produce minimized cost while maximizing profits. Okay, see here. because same inputs they use to produce two products. These are the efficient points. Same combination of inputs we can use to produce same level of output. So what you can see here, they are feasible. Why? And efficient even. Because we took the efficient combinations here. Understood?
Yes, madam.
Okay. Then feasible but efficient. But inside it's feasible because inputs are there. But do they efficient?
No.
No. Why? Because we draw this line after combining the efficient points only. So middle not efficient. Outside not efficient, not feasible even. Why? Because we used, see, maximum possibility efficiency locus here. After that, not feasible to combining inputs because this is the efficient line. Now, is it clear to explain this graph? Two products are there, efficient points are there on the line, in between the graph, feasible because inputs are there, but inputs are not combining in a maximum way to produce efficient output. Outside the graph is unfeasible, not feasible because no inputs are there to produce things, product A or product B. Now clear? To explain this graph, production possibility frontier?
Yes.
Okay, great. Then these are some examples. These all points B, D, C are efficient. A is feasible but not efficient. X is not feasible, not efficient. Now clear? So these all. Then I can give this type of graph to your exam paper. Then I'll ask, explain A, B, C, X, Y points. Then you should write A, B, C are efficient and feasible points. X is not efficient but feasible. Inputs are there to produce here wine and I put cotton here. Okay. But afterwards, this outside the line, the production is not feasible, not efficient. So this curve only gives possibility production. So that's why it is called as production possibility frontier. Clear to you all?
Thank you. Yes, madam.
Yes, Bandara?
No, madam, please again.
Okay. See
Sure.
here, up to now, I think this graph is clear till we get the
It is-
production possibility frontier. Clear up to now?
It is clear, madam. Next.
Okay. Okay. Then let's say after getting this frontier, I am asking, what do you understand? What you can say about B, D, C points? Then you know these points are efficient points. Is it clear? Because we took these points by combining these efficient locus. Understood up to now? How to derive this with
Yes, ma'am.
efficient points? Okay. Then if these points are efficient, the points in the middle are not efficient. Is it feasible? The point A is feasible. Feasible means whether it can be produced here quantity of guns, quantity of butter, two products. Okay. At the A point, is it possible to produce some products here?
No, madam. It's
Why?
not.
Why no? Huh? In between, I mean inside the curve, it's possible or impossible?
It's possible, but it's
Yes,
inefficient.
possible, but not efficient.
Ineff-
Okay. Possible, inefficient. Now understood?
Yeah. Now,
But what you can say about point X?
it's impossible.
Very good. Impossible, inefficient. Not only inefficient, impossible even, because these are the efficient, only efficient points. Afterwards, no inputs to produce any output. Now clear to you all?
Madam.
Okay. Ravindu, clear?
Yes, madam.
Okay, Bandaran? Okay. So
Yes,
here,
madam.
here also the same questions I can ask. What are the efficient feasible points here?
A, B, C.
Very good. What are the efficient? What are the inefficient? Unfeasible point. No, inefficient feasible points.
Yes.
Yeah?
X.
Very good. X, inefficient but infeasible. Sorry. Feasible but inefficient. What is the point? Inefficient, infeasible.
X.
Y.
Right.
Y,
So,
Y, Y.
now what? I think you all understood now. Others all you don't know whether you got. Two students are talking on. Others understood clearly?
Yes, ma'am.
Yes.
Madam.
Okay. Gishani,
Yes.
what point? Gishani, Aravindi. Okay. Any questions you can ask from Ravidu and Bandar. Okay. Okay. So A, B, C are efficient and feasible points. X is inefficient but feasible point. Y is inefficient, infeasible point. Okay. So that's all I plan to teach you today. Next, we'll do interdependence and gains from trade. Okay, new section. Next week. Today we learned about main production. So I hope you got the point, because many new things we discussed. Do your these calculations by yourself. We discuss about the production function. And with the production function, we discussed about various inputs, fixed and variable inputs. So based on that, we discussed two costs, fixed cost and variable costs. So we discussed about the differences. Fixed cost is fixed with the production level, but variable cost is changing with the production level. So this is the production curve we discussed. Then we discussed about various concepts. Basically, three concepts we discussed: total product, average product, and marginal product. Okay. So then we calculated everything. I calculated. Okay. You just saw how to calculate this average product and marginal product. And we draw diagrams. Okay. Then we know how to, if average product is given, how to calculate total product. When marginal product is given, how to calculate total product. Okay. Then how to draw diagram when you are given the inputs and total product levels. Then draw marginal product and average product levels. And now you know the law of variable proportion. It says, any question? Okay. Law of variable proportion says first stage, what will happen to the total production, average production, and marginal production. Second stage and third stage. Then we draw these diagrams and stages we discussed, and isochords we discussed, same quantity. Then from that we came to production possibility curve. Then we discussed efficient and inefficient points. Is it clear now?
Why is it,
Today's section?
if it feasible, why is it inefficient, man?
Sorry?
In the curve,
Yes.
there is a part that feasible and part inefficient.
Yes.
Why is it inefficient, man?
Inefficient because they are not using maximum inputs there. See, when we use the maximum inputs, we can take the efficient locus. That's why we draw these efficient locus production possibility frontier after joining these all. That means in between, it's not efficient. Clear? Okay. Okay, everybody got the points now? Okay, so shall we stop for today? Hello?
We got it, man.
Sorry, okay, not I will share with you. Then the link will disconnect. I will share the PPT with you all in WhatsApp. Okay.